expected to understand the underlying procedures in hypothesis testing, conduct a statistical test using traditional about the population based on the statistic value and the rejection rate. Okay, so the last time I gave you, or the first topic that I gave you in hypothesis testing, the ingress activity for, okay, the mean water consumption. Okay, so here our decision, okay, is, or our task is to formulate a null and alternative hypothesis. What is the probability of committing a type 1 error? Or can we conclude that the mean consumption is not 33.5 cubic meters per month with a confidence level of 95%? Use a one-tailed test. Okay? Since this is a one-tailed test, okay, so here we have mean. Okay, sorry for the typographical error. Okay, as you can see here, we reject the null hypothesis because our computed z value is negative 2.77. Okay, so let's try to connect this. How do we decide? What are the factors when we are deciding uh, when to reject or accept the null? Here in this activity, we we were able to decide. We were able to decide, okay, to reject the null. Okay, so that means that the average water consumption is not 33 point. Okay, so in hypothesis testing, we employ logical sequence of steps, okay, which we call the test of significance. Procedure used by statisticians to determine whether or not to reject a statement about the population. Okay, so we can do hypothesis testing in two ways: the traditional or critical value method and the p-value method. So why is it important? It's important to learn both. The traditional method has been used since hypothesis testing. This is the very, what do you call this, old process. Okay. Nowadays they are now turning to use the t-test instead of z-test. Okay. So the p-value method has become popular because of statistical calculators like SPSS, but now you can use online calculator. Okay, but the use of Microsoft Excel, you can use it. Actually, there are many applications or features of Microsoft Excel where you can use in hypothesis testing. Okay, for each method, the corresponding decision rule that guides us in making conclusion and interpretation, they have their own decision rule. Okay, so let's define some of the key terms that when you are dealing with hypothesis testing. First is the significance level. A test of a test is a probability of committing type 1 error. Okay, test is statistic. This is the value computed, like the z-test, the t-test. Those are example of test statistic. Okay, z-test. This is an example of test statistic. It's a test used to investigate a large sample size. Take note of this, and it's larger than 30. Okay, two means or proportions are significantly different. Okay, so p-value method, we use the p approach or the probability approach. Okay, targets in testing hypothesis. Test whether the difference between two means or proportion is significant or not. Okay, why do we use the term significant? We are, okay, that's why we have the term significance level, confidence level. Okay, z-test or t-test, or are we going to use detailed or one-tail? Mainly our hypothesis, the null and alternative. Okay, null, you will claim that the mean of population and the sample size are equal, and for the alternative, you will negate the mean. Okay, so in this section hypothesis testing, I presented to you two process, two method, traditional and the p-value method. Okay, so I have here seven, but you can sum it, once you already know the process or you already master the procedure, you can shorten the seven steps. Okay, uh, but in your activity you should do the seven steps. Okay, but when you are doing the actual, okay, you can simplify this. Okay, so what is the difference between the two? Okay, let's take a look. The first step, determine the population of interest. For this topic, our population of interest is the mean. For next week, we are going to discuss the proportion. The second step is formulate a null hypothesis and alternative hypothesis. The third one, okay, there is a differences between the two methods. The third one is that check an assumption. A is the sample size large enough for the CLT to apply, meaning that this n is greater than or equal to 30. Do small sample size come from normally distributed population? Usually when you are using CLT, you're assuming that the population is normally distributed. This is for the traditional method. For the p-value method, is there any difference between the two? No. Actually, they have the same. Number four, this one. Choose the significance level. In p-value, there is also significance level. Is the test two-tailed or one-tailed? Okay, then the third condition, determine the critical value from the table. This critical value is only applicable for the traditional or critical method. Because in p-value method, you are going to determine the alpha. Okay, the significance level. Okay, number five, determine the appropriate test statistic. Okay, n is greater than or equal to 30. N is the population variance given. Use z-test. If n is less than or equal to 30 and the sample variance is given, we use the t-test. Okay, compute the test statistic, and for the p-value method, compute the test statistic and the p-value or the probability. Six is decision rule, and the seventh one is to compare the test statistic and the critical value for the traditional method. And for the p-value method, you compare the computed p-value and the alpha. Okay, then draw a specific or draw a conclusion and interpret the result. Okay, take a course of action. If you are doing an action research, you are obliged to do an action based on the description. Okay, in your research later on, you are asked to give your recommendation on your findings. Okay, so this is the decision rule for the two methods. Traditional method, we reject the null hypothesis if the computed value is greater than or equal to the positive critical value, or if the computed statistic is less than the negative critical value. Okay, so reject for p-value, we reject HO if the computed probability is less than the alpha. Okay, less than the alpha. Okay, then do not reject HO if the computed statistic is less than the positive critical value, meaning your critical value falls under the rejection region. And for the p-value, if the computed p-value is greater than the alpha, do not reject your null hypothesis. Instead, you will just restate the null hypothesis, and that will be your findings. Okay, so here are the three formulas or tests when you are testing a hypothesis. These are just examples because we are dealing with a single mean or single variance. Okay, as we go on with the topic, I will be discussing again some statistical tool. Okay, so first one, when the population variance is known, there is a population variance given or standard deviation given in the problem. I mean, for example, in your performance task, I'll be what do you call this? For your performance task, this is the thing that you need to do. It's the hypothesis testing. Okay, I'll be giving the population variance or the standard deviation is population mean all over standard deviation all over square root of n. And for a large population, okay, is applied to find z when the population standard deviation is unknown. The sample standard deviation s. Take note, if your sample size is large enough, meaning more than 30, the sample size is more than 30, but the population variance or population standard deviation is unknown. Okay, by central limit theorem, we'll be using, okay, Okay. In the absence of the population SD, the population variance, we'll be using the sample standard deviation. That's why we will modify the z-test using, instead of using the population variance or population standard deviation, we'll be using sample standard deviation. So as you can see here from this formula, we transform it to this one. Okay, so just say change this because this one is for the population standard deviation, this symbol, and S is for the sample standard deviation. Okay, next, when the population variance is unknown, okay, and your n is less than 30, we use t-test for a single mean. Okay, some students, they are mistakenly using the t-test, okay, but in some research, we are now using t-test for a large sample, okay, because again it approaches, once the sample size is getting larger, okay, it approaches the normal distribution. Okay, so just observe this one. When the population variance is unknown and the n is less than 30, you use t-test. Okay, do not use z-test. Okay, so wait, I just check my chat box if there are any comments. So far, none. Okay, next. So for the illustrative example, okay, so this time, this set of example is for a population mean with testing a population mean with variance and using traditional, both traditional and the p-value method. Okay, so we will be testing a population mean and the variance is given using the traditional and the p-value method. Okay, example one. The leader of Association of the Jeepney Drivers claims that the average daily take-home pay of all drivers in Pasay City is 400 pesos. Random sample of 100 jeepney drivers in Pasay was interviewed and the average daily take-home pay of these drivers is found to be 425. Use a 0.05 significance level to find out if the average daily take-home pay of all jeepney drivers in Pasay City is different from 400 pesos. So assume that the population variance is 8,464. Okay? So 8,464. Next. So let's try to identify what are the given. Okay? Here, so your population mean, okay, take note of this. Population mean, you just need to identify what is the value that you need to test. So you have 400. So meaning this is now your null hypothesis. Okay? And we want to prove that, or we want to test that the mean take-home pay of jeepney drivers in Pasay City is different from 400. Okay, what else are they given? We have a sample size of 100. Else, that is 8,400. Okay, so variance is known. And your n is 100. So we'll be using what test? Okay, so we're going to use the z test because n is greater than 30, which is 100. So your z test now is, okay, sample mean minus population mean all over the standard deviation all over square root of n. Here you have now your sample mean, you have your population mean, you have your n, but you don't have yet your standard deviation. Some of you ask, sir, how does the standard deviation derive? Or how do we solve the standard deviation? Again, based on the definition, the standard deviation is the square root of the variance. So just get the square root of this. So you have 92 as the standard deviation. Okay, so you apply the formula, the t-test, is equal to 425 minus 400 all over 92 all over square root of n, which is 100. The value is, here's the multiplication, okay? So, null hypothesis, CLTS, okay? Now, we get to identify the alpha. The alpha is 0.05, so therefore the signal confidence coefficient is plus minus 1.96. So we'll be using one positive negative 1.96 because uh, of the idea that, okay, we are dealing with a two-tailed test. Okay, so plus minus because we're dealing with a two-tailed test. Okay, so here is now the computation. So the value is 2.7. Okay, now take note of these values 2.72. Okay, so this is now the test statistic. So the test start Z is 2.7. Okay, and your confidence level, okay, or the confidence coefficient is plus minus 1.96. This is just a shortcut. Okay, in your standard normal curve, in your normal curve, your mean here is 400. And just try to locate this 1, 2, 3, negative 1, negative 2, and negative 3. Okay, so your critical confidence coefficient, your critical value is this line. So this is 1.96. This is the critical value. You have here negative 1.96. Okay, take note that this region is the rejection region. Your test statistic, computed test statistic, is 2.72. This is the z value, which is located here. Okay, basically, it falls under rejection region. Okay, so it falls here. This is the acceptance region. Okay, so once the computed test statistic falls in the rejection region, either side, when you are using two-tailed test, so therefore you will what? Reject the null hypothesis. Okay, reject HO. Okay, so that's how you do the traditional method. Just compute the test statistic, appropriate test statistic, Z or T test, and then you compare it with the confidence coefficient. You can use graphical method to identify the location of the test statistic, and you decide what rule are you going to apply. So based on the rule, it says that once the positive Z value or the positive test statistic is greater than the confidence coefficient, we reject the null hypothesis. Sir, what if the computed values falls on the middle? Okay, your decision is to accept because this white portion here, the non-shaded region, that is the acceptance region. It implies that you will accept your hypothesis, null hypothesis. Okay, so that's how we do the traditional method. And here, for the interpretation, we can now say that there is enough evidence. The decision is enough evidence to warrant the rejection of the null hypothesis. Okay, I require you to state this one, to include this. This is the basis of your decision, these values. Okay, the computed test statistic, the comparison, and then your decision, enough evidence to warrant the rejection of the null. And the interpretation is that so the average daily take-home pay of jeepney drivers is not equal to 400. This is the result to consider to be significant at alpha is equal to 0.0511. So we are 95 confident 95% confident that the average daily take-home pay of jeepney drivers is not equal to 400. Okay, so that's your critical method. Okay, so just check if there is any comment. You can comment your questions, maybe in Messenger or uh, here in YouTube. Okay, Jason Kurt. Okay, hopefully the visual or they call this the slide is okay or the video quality is okay. There is quite delay here. Next, let's move on to the next example. P-value. How do we use the p-value method? Okay, using the p-value method, okay, we identify the given. So we already have the given, same given. Okay, the difference here is that we need to give emphasis not on the confidence coefficient, but instead you are using p-value, you need to focus on the alpha. Again, the very common alpha is 0.05 or 0.01. Okay. So compute the test statistic. This is our test statistic 2.72, and you locate this one. Locate in Z table. Okay, in your Z table. Okay, the first two. Okay, like 0.0. So that is now 0.4967. Okay. So 4967, this is the probability of 2.72, the area in the curve. Okay. So we need to subtract this one from 0.4000. It's because this probability is based on the mean. That's why we are subtracting 5,000. Okay. From the center. Okay. So 0.4977. Okay. So the value is 0.003. 0.033. So 0.33, since that is a two-tailed, okay, sir, why did you multiply? So the computed probability is 0.0 by what do you call this? 2. We multiply it by 2 because your distribution or your test is a two-tailed. So when you are dealing with two-tailed, meaning this area is only for the one side. Okay? Because of this 0.5 thousand. That is only on the one side of the normal curve. So we will multiply it by 2 so that we can consider again the. Okay, next. So here, so the value now is 0.0066. You compare it with the alpha, which is 0.05. Okay, so here we can obviously see that this value is less than 0.05. So based on the rule, if p-value, if the computed p-value is less than the critical value, then we reject this null hypothesis. We'll accept now the same way to interpret. They have the same, actually they have the same interpretation. So using the two methods. This is just to show you that the two methods, the result of the two methods is the same. Okay? So in your performance task, maybe by next week, okay? In your performance task, I will require you to use both methods in detail, okay? So that's why I require you to submit your solution, okay? So p-value, example number two. Okay, let's try to start this one. Okay. Okay, why did we use a one-tailed test here for example number two? Because of the word increase. Okay, so those are the terminologies that you need to take into consideration when you are identifying your alternative hypothesis. Okay, because from your alternative hypothesis or from the one tail or two tail, you can formulate your alternative hypothesis. Okay, so increase. So that's why here the symbol we use for greater than the mean 150 because of the word increased. Okay, so critical value is 1645. We take the positive one because it is a one tail. Take note again, I provided you the summary of the critical value of the Z table or Z test, I should say. That is during our previous lesson. Okay. So Z test because n is 60 greater than 30. Okay. So this is the solution 3.02. So okay. So compare Z test 3.02 versus your alpha which is 645, 1.6. The Z test is greater than the confidence coefficient. Okay. So it falls under the rejection region. So our decision now is to reject the null hypothesis. Okay. So interpretation, there is enough evidence to reject. So we conclude that the average expenses for cell phone loads of a high school student in KIS is more than okay, 150. Take note that when you are writing your interpretation, you are using your hypothesis. If you accept the null, then you use your null hypothesis as part of your interpretation. If you reject the null, then you use your alternative hypothesis as as part of your interpretation. Okay? So here's the p-value, same thing. Okay? So 3.02, 0.5 thousand minus okay, 487. Again, if the z value is more than 3, as you can see on the bottom of the table, there is a constant value. Okay? So you use that constant value if your computed z value is beyond 3 or greater than 3. Try to check your z table. At the bottom, you can see there if the value approaches 3 or if reaches 3, there is a constant value. Some books it uses 0.4990 or 89, 87. Okay? So I think they are using 87 mostly. Some of the books using 90 or 89. Okay? So, sir, um, basically, okay, if you see that the value, okay, that 0.05 is quite small. Where is 0.05? What is the probability of 0.05 in a one-tailed test? So in a 0.05, uh, confidence value or probability, I have 95% rejection. Sorry, 95% confident. Okay, if you are using one tail, that is this is right tail, right tail. Okay, right. So meaning that the right portion of the 0.05 is 0.95. Okay, so if ever any possibility that my value would be greater than my alpha. You just try to analyze it. Okay? Sir, my computed value is greater than 3. So what's the problem? Just try to analyze it. Okay, I'll get this value. It's 0.5 thousand. So drop it from 0.5 thousand. Is there a possibility that I get a value which is greater than 0.05? Okay? Just check the chances. what are the chances that I'll get 0 points greater than 0.05? Sir, why do I need to consider that I need to check the probability of getting a p-value which is greater than 0.05? Because if you got a value that is greater than 0.05, or for this specific example, I'm using zero point zero 0.05, or your critical value, 0.01, 0.10, okay, if there is a chance to get a greater value, then what? There is a large for you to accept the null hypothesis. Okay? So just try to analyze it. Okay? So because of this decimal, yes, decimals are quite they call this one confidential or important in solving, but try to check first the probability or the chances when, if you get a lower value or a greater value than your alpha. Okay, so that's your p-value method. This one table. This one is for uh, left. I hope you already tried to study this one also. 147, same result. Maybe we can just check the t-test. Example of t-test and the z-test. Okay, this one. What if we are to test a population mean when the variance is unknown and n is less than 30? Take note of this. Variance is unknown and the population size is less than 30. Okay. So take note again, check the sample size. The sample size is 15. So, as mentioned earlier, if your sample size is less than 30, then you use t-test. Okay? So, from the given, we can formulate this parameter of interest, okay, which is mean, basically mean. Okay? So, why again we use a one-tailed test because of what? This is greater than 195, more than more than 195. Okay? So here